All right, question number 3. Again, we have 2 parts. We're going to sketch the graph of this function. It says check with a calculator, and then it says we're going to describe how we can get the basic exponential, how this graph will look different from the basic. So this is 5 over 2, which is 2.5. It's still bigger than 1. What's going to happen in this graph is still exponential growth. It's going to get shifted right 2 units. So that's all we're going to do. Start with the basic graph of 5 over 2 to the x power, and then we're going to shift right 2 units. It's up there with the x. So shift 2 units to the right. B looks to be the correct one, and we're going to do 5 divided by 2. So we're going to start with that basic function and then shift right 2 units. All right, and then we're actually going to apply that to this graph. So again, exponential growth, or exponential. We got to change the base. So the base is e. We're going to change that to 5 divided by 2. 5 divided by 2. All right, so we change our base, and all we're doing is a horizontal shift 2 units to the right. I wonder why it looks so different now. Horizontal shift. We're going to just type in the 2. Check that. Question 4 says we're going to sketch the graph. We can check it with a calculator. We haven't needed it so far. We're going to keep going. We're going to describe how the graph here is going to be different from the basic. So the only thing we have here is this multiple of 2. When you have a multiple in front of the x, it's going to do a horizontal dilation, stretch or compression. I describe with my students, anything you see with x is going to be opposite. So it looks like it's being multiplied by 2, but what's actually happening is you're going to divide by 2 or multiply by half. The way you really see what's going on with the x is think about taking a basic equation. So let's just say, for example, if I had y equals 2x minus 4. Right now, this equation is solved for y. If you were to solve for x to get x by itself, you would immediately notice everything doing the opposite. So the first thing I would have to do is add 4. So instead of what we were doing, subtracting 4, we're actually adding 4. So the effect on x is the opposite. So we end up with a y plus 4 equals 2x, and that will cancel out. And then we have 2 times x. To get rid of times 2, we have to divide by 2. And so then you can see the effects of what actually happens to x. So when you solve for x, now we see it's being divided by 2, and we added 4 instead of subtracting, which you can simplify that, so that might change as well. So anyway, this 2 up here as a multiple is going to actually divide the horizontal axis in half, or shrink it by half. So we're going to start with this graph, and it says since the constant factor in the exponent is 2, the graph should be shrunk horizontally. Okay, now if this was less than 1, like a half or something like that, then we would multiply it by that factor. And now we're going to do that to the graph. So exponential, the base is e, so I can leave that. Then we are doing e to the 2x power. So we're going to have a horizontal stretch shrink. Shrink. Now here, I don't know if they want us to put the 2 or 1/2. I'm just going to put the 2. I feel like maybe we want to do the 1/2, but we'll check it out and see. So no shifts. All we have is a horizontal compression by a factor of 2.